Viscosity is a measure of a fluid's resistance to flow. Bucy compares the viscosities of 3 alcohols by measuring the time it takes 25 milliliters of each alcohol to flow from a pipette. This time is an indication of the viscosity of each alcohol. Formulate an investigative question for Bucy's investigation. Which alcohol flows fastest? Which alcohol flows slowest? Which alcohol has the greatest viscosity? Which alcohol has the lowest viscosity? You needed to have the alcohol and the concept of either time or viscosity in that question clearly. Which alcohol in the table has the highest viscosity? Then there's this word explain your answer by referring to the results. So the first thing that we're going to do is we're going to say the one with the highest viscosity is propan-1-ol, and most of you manage that without any difficulty. Then you need to say the following things. It took the longest time, and then you somehow need to link that back to the fact that it is therefore the greatest resistance to flow. That's your third mark. Name the functional group in alcohols. The functional group is the OH group, and it is called the hydroxyl group. In this case, they asked for the name, and therefore OH is not good enough. So you only got half of that, and might not even in the final exam. Explain the trend of viscosities in the table by referring to intermolecular forces. So the first one is a trend. So larger alcohols, higher viscosity. Larger alcohols, greater IMF, greater intermolecular forces. But it's an explanation, it's not just a fact. You're explaining that trend. So now you need to say, how come? Is there a greater intermolecular force? And the reason there's a greater intermolecular force is because they have a larger electron cloud. And maybe we can even just go straight into larger electron cloud surface area for greater forces. Of attraction between particles. Not greater bonds, remember, it's forces of attraction, it's intermolecular forces, it's a different thing. Bucy now wants to compare the viscosities of 2 alcohols with the same molecular mass. So now you're not getting greater molecular mass or bigger molecules, so you can't say the one's bigger than the other. These are chain isomers. They both have the same functional group, alcohol. They both happen to be in the same position, 2 alcohol. The only difference is the structure of the chain. Butan is a 4 in a row, methyl propan is 3 in a row with a side chain of the 1 extra carbon. Draw the structural formula of 2-methyl propan 2-ol and butan 2-ol. So the butanol has got the 4 in the chain with the alcohol coming off the second one, and here's the propanol 3 in a row with the alcohol coming off the second one and off the second one a methyl group. You need to tell me which one's which, obviously, in your drawing, and they wanted full structural formulas of that. These 2 compounds are isomers. Define an isomer. It is same molecular mass, molecular formula, different structural formula. What type of structural isomers are they? And they are chain structural isomers. Which one of these 2 alcohols would have a higher viscosity? Explain your answer. So here we have got a long chain and a large electron cloud distribution. Here we have a smaller surface area. So small electron cloud surface area. This is a large electron cloud surface area. And which one of these two alcohols would have the higher viscosity? Therefore, greater IMF, therefore higher viscosity. And then give the condensed structural formula and name the positional isomer of that over there, the butan 2-ol. So it's a positional isomer, so this ol just needs to move. So all it's going to do is it's going to hop onto the next carbon. But if it hops onto the next carbon, 1, 2, it's still butyl 2. So we need to make it hop onto this carbon over here, and then it becomes butyl 1-ol. So butan 1-ol, and then we're going to have to draw it. So it is CH2OH, CH2, CH2, CH3. If you went OH or HO, doesn't matter, CH2 and then carried on with it, it was also fine. I find I can't really draw structural isomers, at least condensed structural formulae, unless I've drawn out the big one, because then I can see what's going on. Some reactions of butan 1-ol are represented in the flow diagram below. P, Q, and R represent organic products. Product P is formed when butanol is heated in the presence of concentrated sulfuric acid. Name the type of elimination reaction. It's an elimination reaction. I'm telling you that. So you're going to take the butanol and you're obviously going to get rid of the alcohol group and you're going to be left with butane. But if I get rid of OH and an H, I am left with some water. So what is the type of reaction that takes place? It is a dehydration. I'm getting rid of water. Write a balanced equation for the reaction which takes place using structural formulae for organic compounds. So once again, I've given you the fact that it was an elimination. That was supposed to help you get the rest of these marks. Sorry, I made a minor error over here. This is butene. Obviously, from an elimination reaction, you land up with butene. So I've taken the butanol, I've eliminated the hydrogen and the hydroxyl group, leaving me with a double bond on this last carbon. And if they ask me for structural formulae, don't forget you've got to draw water as a structural formula. And don't forget that water is actually a bent molecule from your study of molecules. Name the homologous series to which the organic compound P belongs. This is a alkene. Product R is formed when butanol reacts with ethanoic acid in the presence of an acid catalyst. Name the type of reaction. It's an alcohol and a carboxylic acid. We're into an esterification reaction. Name and give the structural formula of the product. If it's butanol and ethanoic acid, and that's luckily this alcohol's on the last carbon, or the first carbon if you prefer, you're going to land up first with the alcohol, so it's butyl ethanoate, and then you're going to go butyl 1, 2, 3, 4. Then you're going to put the oxygen that divides them. Then you're going to put C, C for eth, and the O8 bit is where the double bond O goes. And then you are only going to land up just filling up the spaces with hydrogens around the molecule. When hydrogen bromide reacts with butan 1-ol, compound Q, a haloalkane is formed. Give the type of reaction that takes place. If I'm going to take an alcohol and make it into a haloalkane, I need to take off the ol group and stick on the halo group. That means it is invariably a substitution reaction. Give the IUPAC name of that haloalkane that is going to be formed. So it's hydrogen bromide over there. So I'm going to take the butanol, I'm going to add HBr, I'm going to form, instead of butane 1, it's butane 1-ol by the way, I'm going to form butane 1-bromo, but we don't write it like that. We call it 1-bromo butanol, or at least butane, because we've got rid of the ol bit. And I've pulled off the ol bit and given it in where the bromine was, and vice versa, so that stuff is called water. It's a hydrogen and an OH, water. But-1-ene, an unsaturated hydrocarbon, and compound X, a saturated hydrocarbon, both are able to react with chlorine, as represented by the incomplete equation below. Explain what is meant by the term unsaturated. It means that there is at least one double or triple bond in the organic molecule. Identify the type of reaction that occurs in reaction 1. We've got a double bond here, ene, so it's going to be an addition reaction. It's a special addition reaction though, if you take a look at it. It's chlorine being added, so I would have taken a halogenation as well. Reaction 2, what's happening is I've got something, and then the chloros are going on, and something's coming off. That appears to be a substitution reaction. Something comes off, something goes on. Write down the structural formula of product of reaction 1. If I'm going to open up the bute's double bond, so there was a double bond here, over here, but I am now opening it up. Boom, boom. Okay, these are all the original hydrogens that were in place. When I open up that double bond, I get both my chlorines have to be on number 1 and number 2. That's showing that reaction. What reaction condition is necessary for reaction 2 to take place? And I'm not great with these conditions, but they might come up, so you do need to know them. This one takes place in the presence of UV light. UV light can also be called sunlight, and some heat. So that's what needed to come through. It's not a water bath. It's proper heat from, the heat has to have come from UV light or from sunlight. It's not heat that came out of water bath. Write down the IUPAC name for this X. Well, before I put the chloro on, I needed to have had some other sort of a propane, and maybe I just had plain propane over there. If I have plain propane, yeah, I would have had hydrogen come off as a product. So let's just unpack that a little bit. If I had put propane here, and then I got chlorine coming onto the molecule, hydrogen would have come off the molecule, and I would have had some HCl. It isn't dichloro. There's only one chloro that goes on there. So there's still one chlorine left over at the end. So write down the product formula or name. So it's HCl, hydrogen chloride. Hydrogen chloride is only hydrochloric acid when it's dissolved in water. So be a little bit careful about saying hydrochloric acid. It's actually hydrogen chloride. So this was propane, and that was hydrogen chloride. Ethanol is also commonly used, called ethyl alcohol. This is all like an introduction. Alcohols are useful starting materials, and they're going to take place in 2 steps. So the incomplete chemical equations below are in these steps. I've got the alcohol ethanol. It turns into something in water, so that's an elimination reaction. Compound step 2, I take my what have we got? Ethene, yes, because it's an elimination, so I've created the double bond. So that's going to be some ethene, and I'm going to add something to it to make it into ethane. I have to add hydrogen to it in order to make it into ethane, and that is a hydrogenation, or an addition reaction. Write down compound X's structural formulae. So it's ethene, so it's C double bond C with two H's coming off it. And then identify the type and the name of reaction occurring in step 2. It is either an addition reaction or a hydrogenation reaction. And then it is identify compound Y, that is going to be hydrogen. Oh, hang on, you have to give me both. You have to give me the type and the name. So it is an addition reaction and a hydrogenation reaction. Those are for the 2 marks. Addition gets you 1. That is the type, and its special name is hydrogenation.